Pre-statistics. Determining an appropriate viewing window when graphing linear functions. Lesson objectives. Change the viewing window settings on the TI-8384 calculator. Number 2. Determining the appropriate viewing window on the TI-8384 when graphing a linear function. Lesson objective. The viewing window determines what part of the function will be visible on the calculator screen when the function is graphed. This window is set by values of the following: xmin, that's the smallest value that can be seen on the screen on the x-axis. Xmax is the largest. XSCL is short for xscale. This is what we are counting by on the x-axis. The default value is 1. The ymin is the smallest value on the y-axis, and of course xmax is the largest. And finally we have yscale, which has a default of 1. Now here's a visual. Here's the value of xmin, here's the value of xmax, and xscale is this distance. It's how far the tick marks are from each other. The ymin is down here, smallest value on the y-axis, and this is the ymax. And of course this is the yscale. So these values can be changed. A common notation for writing the window settings of a graph using the TI-8384 calculator has the following form. We begin with the x values. We start with the smallest, xmin, comma, xmax, then xscale, by the ymin, ymax, and finally the yscale. These settings are assessed by pressing the window key on the graphing calculator. The standard window, which is also the default window, has the following settings: -10, 10, 1 by -10, 10, 1. So the xmin is -10, xmax is 10, the scale is 1, and that's the same values for the y. This window setting can be quickly defined by pressing the zoom key on the calculator and then the number 6. This is called the zoom standard command. So we press zoom and then 6, or we press zoom and scroll down to number 6 and hit enter. Once we perform the zoom standard command, we get this graph. So this is -10, this is -9, -8, all the way to a +10, and the same as for the y-axis. This is -10, -9, -8, -7, all the way up to a +10. If we press the window key, we see that these values have been set by the zoom standard command. Many functions graphed by a graphing calculator are not fully visible when using the standard window setting. In many cases, the entire function is not visible. Determining the appropriate window settings is an important skill when graphing various types of functions. So we're going to look at some examples. Lesson objective number 2. We'll begin with some basic guidelines to set the window settings for a function. The first thing that we want to do is compute all possible intercepts. This includes both the x-intercept and the y-intercept. Next, knowing the type of function, the general shape will help us with the viewing window. How many curves is the function going to have? Is the function a straight line? What's the end behaviors of the function? All these can help us set the window setting. Next, determine if there's any minimum values or maximum values. Now for this class, we will begin looking at linear functions, and they do not have a minimum or a maximum value in most cases. But when we move to quadratic functions, they will have a minimum value or a maximum value. Next, we want to determine, is there any possible asymptotes? Linear and quadratic functions, for the most part, that's not going to be the case, but when we move to exponential functions, they will have asymptotes. Next, we want to keep in mind if a function has a restricted domain. So for example, if we're doing a model and negative values do not make sense in the terms of the problem, we really don't need to graph the negative values, so we want to take that into account when we set our window settings. And finally, if you're not sure, we can always use the table command, which is second key and the graph key, and we can get a view of the x and y values of the function. This will help us set the viewing window. So let's do some examples. We'll begin by doing a very easy one, y equals x minus 3. Now when we graph this in the standard viewing window, we'll be able to see the important features of this linear function, both the x-intercept and the y-intercept. So we have our graphing calculator. To graph, we go to the y equals button. We want to make sure there's no stat plot on, and in this case there's not. If you do need to turn the stat plot off, you move your up arrow key and hit enter, and that will turn it off. Now if I hit enter now, it's going to turn it on, so I'm going to leave it off. So now we just move back down by using the down arrow key. Now we want to graph y equals x minus 3. So we have y1 equals, next becomes our x variable, which is this key, and then minus 3. Okay, now we need the graph, and if I hit my window key, I can see right now my window settings is the standard viewing window. So now I can hit graph, and here we have our function. The y-intercept is negative 3 and the x-intercept is a positive 3. If we hit second and graph, which is our table command, we can see when x is 0, y is negative 3. That's the y-intercept. And if we scroll down to 3, when x is 3, y is 0. This is the x-intercept. So for this graph, we can see our intercepts very easily by using the standard viewing window. Now let's look at an example where that's not the case. So let's look at this linear function, y equals negative 2x plus 60. So now we go to our y equals. We want to type our function. So first I'm going to hit clear, and then I'm going to type in negative 2x plus 60. Hit graph, and it looks like the calculator didn't do anything, but it did graph it. We just can't see it in the standard viewing window. So our first step is we're going to determine what are the intercepts for this linear function, and that's going to help us determine what is the window settings need to be in order to see this function. So to find the y-intercept, we let x be 0 and we solve for y. So if x is 0, we have negative 2 times 0 plus 60, and of course that's 60. So the y-intercept is 60. The order pair is 0, 60. To find the x-intercept, we let y be 0 and we solve for x. So we have to subtract 60 to both sides, and then to solve for x we divide by negative 2, and we have x is equal to 30. So the x-intercept is 30. The order pair is 30, 0. So let's go back to our graphing calculator. Okay, so we want to change our window settings. We know that the x-intercept is 30. So if I hit window, so I want my x-min to be less than my x-intercept, and I want my x-max to be more. So I'm going to leave the x-min at negative 10, since we have a positive 30 for the x-intercept. Using my down arrow key, I'm going to change the x-max to something a little bit more than my x-intercept of 30, and I'm going to use 40. This span between the x-min and x-max is 50. So instead of counting by ones, I'm going to count by, say, 5. The y-intercept is a positive 60, And I do want to see the x-intercept, so I'm going to leave the y-min -10 so I can still see the x-axis, but I'm going to change the x-max to something more than 60, and I'm going to use 70. Now this distance is 80, so I'm going to count by 10. So my y scale is 10. Now you may ask, what is this XRES? That's the resolution, defaults 1. You never really need to change this. Now when I hit graph, I can see both the X and the Y intercepts, and clearly I can see the x-axis and the y-axis, and I gave it a little bit of room for both in case I want to use the trace feature. So if I hit trace, it's going to display what the function is, y equals -2x plus 60, and it's also going to give me the order pairs on this graph. So now I can still see the values, but I can also see the entire graph. And I can move for certain values. So this is our first example, and we will look at more examples in the second video. Thanks for watching.